Let's embark on a journey into the fascinating world where artificial intelligence meets metamaterials. Picture AI as the brainchild of computer science, a realm where machines learn to mimic human intelligence. They analyze data, recognize patterns, and even make decisions. Now, imagine metamaterials as the rebellious cousins of natural materials. These artificial structures exhibit extraordinary properties not found in nature. They bend light in unusual ways, leading to groundbreaking applications. Think of metamaterials as the building blocks of invisibility cloaks, a concept straight out of science fiction. These materials manipulate light, making objects invisible to the human eye. The possibilities seem endless, pushing the boundaries of what we thought possible. In simple terms, AI is the clever architect, and metamaterials are the magical bricks. Together, they hold the key to unlocking a future we could only dream of.
Designing metamaterials is a complex puzzle, demanding precise arrangements of tiny, repeating structures. This is where AI steps in, acting as a master builder with unmatched precision. AI algorithms can analyze vast datasets, identify patterns, and predict how light will interact with different metamaterial designs. Imagine AI as a tireless artist, sketching and refining countless designs until it finds the perfect one. This process, known as machine learning, allows AI to optimize metamaterials for specific applications. For example, AI can help create metamaterials that absorb specific wavelengths of light, rendering objects invisible to radar or even the human eye. This powerful partnership between AI and metamaterials unlocks the potential for advancements in various fields. From enhancing telecommunications to revolutionizing medical imaging, the applications are as vast as the cosmos itself. With AI as the architect, the future of metamaterials is brimming with possibilities.
Metamaterials are not merely materials, they are a symphony of light and matter. Imagine a conductor leading an orchestra, each instrument playing a specific note to create a harmonious melody. Similarly, metamaterials are meticulously designed to manipulate light waves in extraordinary ways. These materials owe their exceptional properties to their intricate structure, crafted at a scale smaller than the wavelength of light itself. This intricate design allows metamaterials to